This is Secondary 1 Honors Quarter 2, Part 2, Video number 9. We are going to use graphing calculators and row operations to solve systems of equations. And this time we're going to be doing at least 3 variables with row operations. You will need your notes, graphing calculator, and a pencil. Number 11 on your notes paper has this system. And so if you recall how to do this system with row operations by hand, you need to write this down. So first we do an augmented matrix. And this is what the augmented matrix looks like. And then I'm going to go quickly through these steps that we're going to do. So just remember how to do this. We're going to leave a trail. Remember, leave a little trail of what you're doing. So the first thing that we're going to do is remember that we're trying to get this reduced row echelon form where you have ones and then zeros everywhere else. And then these numbers will be our solutions. Okay, so the first thing we're going to do is we're going to try to get zeros. Don't worry about where you have your ones right now, just get your zeros. And so I'm going to try to get zeros, first of all, in this position right here. I'm going to take 5 times row 1 and add it to row 2 and put it in row 1. So here's what I'm going to do. 5 times 2 is 10, and 10 plus 3. And then 5 times negative 1 is negative 5, and then add the 5. And then 5 times 12 is 60, and then add the 5. And when I do that, I am going to get the 13, 0, and 65. The next step then is I'm going to take my row 1 and divide it by 13, and I get 1, 0, and 5. I'm going to leave row 2 alone. I have not touched anything with row 2. I've just used it to help accomplish my purposes. The next thing I'm going to do is, now that I've got a 0 where I want right there, I'm going to now go for a 0 in this position. So I'm going to take negative 3 times everything in row 1, and I'm going to add it to row 2, and I'm going to put it in row 2. So you'll notice my row 1's not going to change. I'm going to have negative 3 times 1 is negative 3 plus my 3. And then I'm going to do negative 3 times 0, which is 0, plus my 5. And negative 3 times 5, which is negative 15, plus my 5. When I do that, I will get the 1, 0, and 5. Like I said, it's not changing. And then I'll get 0, 5, and negative 10. Since I notice that there's a common factor, I'm going to take row 2 and divide it by 5, and I will get 0, 1, negative 2. This first row still hasn't changed from the last time. And now, if you notice, I now have my reduced row echelon form, because in this part right here I've got my 1, 0, 0, 1. That tells me that x is equal to 5 and y is equal to negative 2. Remember that we can check this by putting it back into our equation up above, and it has to work in both equations. So I've got my 2 times x minus y, and that's equal to 10 plus 2, and that's 12, and so that works. Then I'll do the 3 times my x and 5 times my y, and that's 15 minus 10, and that is 5, which is what I want it to be, so I have verified that that is true. And that's just a reminder about how to do row operations to get reduced row echelon form. If you're interested, if you like puzzles and things like that, you might be interested in watching the additional videos that I have written links to on the worksheet. It shows how to do row operations for larger matrices like 3x3s in these videos without a calculator. The last one on that list is one that I did. The other ones are a series of 4 videos on YouTube that another teacher has done. And so you can watch those if you're interested. You don't have to, because you won't be doing this by hand, but you might like it. Okay, number 12 on the worksheet, we're going to have this system. This is a series of 3 equations. We've got 3 variables. We can do row operations as demonstrated in those videos I referred to a second ago, but we're not going to do this by hand. We're going to use our calculator. So the first thing we're going to do is we're going to enter it as an augmented matrix. So because I have 3 variables, I'm going to have a 3 by 4 matrix because I've got 1, 2, 3, 4 columns, and so I have to enter all of it. So I'm going to go a 3 by 4 matrix, and we're going to call it matrix A. And then you're just going to enter 2, 3, 4, -1. Don't worry about this, the line that separates it. That's just to visually help us separate it. You don't have to do anything. And so when you put it in your calculator, it's just going to look like that. And then put all of those in, and then make sure that you remember to quit. So pause this and get those all in there. Okay, the next thing we're going to do is we're going to have our calculator help us get this into reduced row echelon form. The calculator will do all of the row operations for us. And so the way that you get your calculator to do that is here are the keystrokes that you will enter. Once you've got your matrix entered in as matrix A, you're going to type second and then matrix and then the math. And then you're going to scroll all the way down, so just keep going down. It's got a picture on your screen, and it's going to say B:RREF. And that RREF stands for Reduced Row Echelon Form. Okay, now we need to tell the calculator what do we want to find reduced row echelon form of. So on your screen, on your home screen, once you've got reduced row echelon form, it's going to say RREF, and then you need to tell it what you want it to do with that. So you're going to enter, and that's how you get the RREF on your screen, and then you're going to go in and you're going to type in matrix A. So remember the second and matrix like you've been doing all this time. Then you're going to get matrix A, and you're going to enter, and what happens next is awesome. Okay, what you see on your screen, or what you should see if you did it right, is you should see this augmented matrix. What the calculator's done is it's done all the row operations for us with the least effort on our part. You notice that you have reduced row echelon form right there. That tells you that it is done. If you don't see that, then something's different. So that tells us then that x is equal to 2, y is equal to -3, and z is equal to 1. So those are our solutions for our system. And so now that becomes the fastest way ever. Okay, well, remember that we're going to check this, so very quickly with your calculator if you need to. It's probably just as fast with your calculator with this many numbers, so you can just do 2 times x plus 3 times y plus 4 times 1, and then 6 times, notice you don't have an x right there, so make sure you don't use the 2 on the second one. So 6 times y, and then minus 3 times 1, and then the last one, x plus 4y minus 2z. You get the -1. That works. -21, that's true. -12, that's true. So now we're going to put our check mark in our box because we have verified, guaranteed $5 correctness. Okay, let's do number 13. You're going to go in your calculator, you're going to enter the augmented matrix. Remember, this one is going to be a 3 by 5. Sorry, let me say that over again. It is going to be a 1, 2, 3 by 1, 2, 3, 4. 3 by 4 matrix. And so this is your augmented matrix. This one doesn't have any missing variables anywhere, so you don't have to worry about zeros, but you always need to be on the lookout for that because that will mess you up really badly if you miss it. So enter that into your calculator. Don't forget to quit when you're done entering your matrix. And then you're going to ask your calculator to do put it in reduced row echelon form. So here's the steps again. So you quit, and then you're going to go through this second matrix. You find the reduced row echelon form. Remember, you have to scroll all the way down for that. And then you have to tell it what matrix do you want to find reduced row echelon form for. This is what you will get when you do reduced row echelon form for this number 13. And notice that you've got your ones and then everything else is zeros. And so that's how you know that you've got this correct. And that means that x is equal to -2, y is equal to 5, and z is equal to 1. So go through the checking process. So I'll just let you go ahead and do that real quickly. You need to make sure you know how. On your test, you're not going to have very many chances to prove that you're right. So you need to make sure that you've got it, that you know how to check it, and that if you didn't do it right, you go back and fix it. So we see that everything works. And so I will check my box. Okay, next one. Again, a 3 by 4 matrix. Go ahead and pause this and find reduced row echelon form and then press play. Okay, this is the reduced row echelon form, and that might look like that's a little confusing. If you notice, you do not have these ones there like you're supposed to have, and in fact you have ones in all the wrong places. So has the calculator made a mistake? What's happened? What this actually means when you get something like this, it means there is no solution. There is no set of variables x, y, and z that will make this system work that will satisfy all three equations. So there is no solution. And remember from before, we call that a singular matrix, and that means the same thing as no solution. And so you can write no solution. You need to know that that's also called a singular matrix. Now, how do you check something like this? Because we do need to check when you get something like this, you want to make sure. So you can verify one of two ways. You can either find that the determinant of our coefficient matrix is equal to 0. Remember, for instance, with Cramer's rule, if your determinant of your coefficient matrix was 0, then when you were finding for x, you would do like x, the determinant of the x matrix divided by 0, and that's undefined, so you could not solve that system of equations. So that's one way that you can verify this. The second way you can verify is you can show that the coefficient matrix, so here again, this matrix right here, show that it has no inverse. So remember that if a matrix doesn't have an inverse, you can't solve it. So the way you would do that is you would enter your coefficient matrix as matrix A, then tell it to find the inverse, and write on your paper what the calculator says when you do that, because that's a really good way to check. So pause, do that, and then write down what it says. Okay, once you've done one of those two things, you don't have to do both, but do one of them, then you have verified that. Okay, last question, number 15. This one is a 4 by 5 matrix. It's got 4 variables, w, x, y, z, and so therefore we have 5 columns. So you're going to tell your calculator that it needs to do a 4 by 5 matrix. So that's the biggest one you've done so far, but the calculator doesn't care, it can handle all of it. So go ahead and enter in all of your coefficients. Remember, you don't have some of the variables where you think you might need to have them. So you're going to have to enter zeros in for that. So this is your matrix that you should enter, your augmented matrix. I have put in red all of the places where you have zeros instead of some other coefficient. So make sure you've got that entered correctly. Find reduced row echelon form. So go through that process, and this is what you should get when you've done that. And that means that w is equal to 1.5, x is equal to 1, y is equal to 0, and z is equal to negative 2.5. Go through the process to check that. It's kind of hard when you think about 4 variables, 4 equations, it has to satisfy all of them. So for example, on your test, you will need to make sure that what you've got on there is correct. You will not have many chances to do that, so you need to make sure that you've got it and that you can verify it. Okay, you're now prepared to complete numbers 11 through 22 on your Part 2 worksheet. You need to make sure that you've practiced enough that you can do this entire process on your own without asking how to do it, or I don't remember how, because on your test you will not receive any help on that process. So make sure you've practiced enough that you remember how to do it and you know how to explore. You can go through it enough that you can find the answers. This is the end of the video.